My name's Chris Weiner. I'm the director of marketing for OpenText and one of the hosts of the hackathon. Um, what we're going to do today is we have gracious Google has been gracious in their support throughout this, and they've been gracious enough again with Vivian and Faisal to come and talk to us about their services, how you can use them, and give you a little bit of context. So without further ado, I'm going to hand it off first to Vivian, let her do her own introduction, and then she'll hand off to Faisal, and then we'll come back for maybe a couple minutes of Q&A. So without any further delay, the floor is yours, Vivian.
Awesome, thank you. And thank you for having me. Great to meet everybody. I think between Faisal and I, we have a little bit of a show and tell plan, some demos, just a little bit of a walkthrough, but feel free to ask questions. I think as we go through, happy to be interactive and happy to answer questions the whole time if that's more helpful for folks. Although I figured, instead of letting this be open-ended, I'd at least have a little bit of some preparation. So don't be shy and feel free to kind of interrupt as we go. I'm Vivian Neely. I am the lead product manager with the healthcare APIs in Google Cloud. So largely I oversee a suite of various different data products that are built for the different modalities of data that we see in healthcare. So clinical data is very different than imaging data, x-rays, things like that, which is different than high frequency kind of device data, the way that you would capture ICU data or even just something as simple as a Fitbit looks a lot different than what you would be capturing at kind of the level of how do I make an appointment? And so I oversee all of those products, and I'll talk a little bit about them, and I'll do a little bit of a demo, but happy to take questions as we go. So I don't know if you want to do an intro now or if you want to wait until
I can wait. I can wait. You're in the zone right
now. Awesome. Thank you. Yes. All right. So let me go ahead and I think it says the host disabled their screen sharing. I don't know if we can undisable that. But I'll do my spiel with or without visualization. You can see how good I am at interpretive dance. So the one that we kind of are focusing on, especially within healthcare at large, is actually this thing called FHIR. FHIR actually stands for Fast Healthcare Interoperability Resources. And the idea of interoperability at large is patients, when they were coming into healthcare systems, where their patient data was not following them between different different stays and kind of different encounters. So if you went from one doctor to another, it was difficult to keep the longitudinal view of your health. And that's actually really important because a lot of the time, things that happened earlier in your life actually manifest themselves later in life. And if you're being seen by a different doctor in a different state, they might not know something that's extremely critical to what happened 20 years ago. And so what was happening is actually we had diminishing kind of quality of care because we didn't have the ability to share and exchange data amongst providers and amongst hospitals. Part of this is because the way that the hospital systems work is they all have very proprietary systems built in place. So the electronic health records is actually basically a software that was built for billing, but now is kind of the place of data entry for most physicians. And those pieces of software are extremely locked down. They are built on a proprietary backend schema. It is very difficult to kind of connect to, even from an application perspective, connect to and integrate with those kind of walled gardens that we know as electronic health records. And so since that happened, things. So since that happened, that is really fundamentally why it was so difficult for this data exchange to happen. And it got kind of escalated up enough that the US government actually stepped in, and this is happening across any of the countries that actually have kind of not centralized public health care, where they said, we are going to go forward and make interoperability laws or interoperability legislations that say all healthcare data needs to be able to be accessed on in a secure way with correct access controls in place and identification and consent all within place. But they actually need to be able to access this data in a standardized fashion. So rather than each individual software or each individual hospital having their own way of data sharing, the governments across the globe right now are saying that's basically it's a negative impact on patients. We can't kind of follow their whole longitudinal health. We can't treat patients correctly. So we are going to make it a requirement, and in fact, payment can be withheld in some of these cases if a hospital or a care system doesn't allow for multiple different thank you, awesome, multiple different kind of what we call there's a few different ways of doing this. And so let me pull up, and I think I'm probably already, okay. Yes, perfect. We're on the right slide. Okay, so I mentioned, slideshow. So I mentioned a bunch of different hospital systems, a bunch of different types of data. They're all setting it in different ways. It's very difficult for patients, caregivers, even providers to be able to access this across the board. So we get to legislation like this that says, this is ridiculous. We need to be able to have provide quality care regardless of where the patient is or regardless of where they're being seen. So this was that's happening in 2016. There was recently legislation proposed in Canada. There's some being proposed right now in Australia. This is kind of a pattern we're seeing across the globe, which is let's standardize access in a conformant API way. And so what that really breaks down to is we have now these called interoperability APIs. There's kind of traditionally a few buckets of these. So there's patient access ones, which say patients should be able to access their data. Now, patients should be able to access their data in various different, either from a physician or a care system, but also from their insurance, so that you can be able to actually switch insurance and not lose your previous status or your previous kind of, they understand who you are as a person and the health records you're taking with you. There's a second bucket, that's the provider directory. You should be able to know and have a comprehensive list that can be accessed automatically so people can build, say, applications. ZocDoc is a great example where they're actually operating almost entirely on these interoperability APIs that are pulling provider directories. And then there's payer-to-payer, where you need to be able to do things like prior authorization when you're seen. All of those are the standard APIs that we are kind of rolling out as a healthcare industry. And why that's happening, other than we need to be able to access our data, patients need to be able to, providers need to be able to, it's also so that the industry can build better applications. There's probably a lot of people in this room who have had logged in to their patient portal and then gone and got care maybe somewhere else and logged into a separate patient portal that looked different, felt different. You don't know where the buttons are. Your password is different than the first one. And it could even have been in the same overall care system. So I'm sitting in Boston right now. Partners Health is largely one of kind of the overarching health systems in Boston. Even if you're seen in the partner system, you actually have a different patient portal and access to your physicians depending on which hospital you went to. And so when we did this, we also built a layer for applications, and that's what's called Smart on Fire. It's access, authentication, and really intended to kind of help the app developers build on top of these APIs. All of those APIs are in what's called Fire. Fire is the one I mentioned, fast healthcare interoperability resources. It's a bit of a misnomer because it is an API specification. It tells you how to query data, what that data type is, what search parameters are available to you, etc. But it's also a data model where it tells you exactly how to store the data. Blood pressure is stored in this particular fashion, or are all of our kind of the classic data and analyst problem of having to munge the data and make sure that the same way that they're that they're presenting first and last name, etc. Fire actually went ahead and is actually defining all of those characteristics so that the analyst community doesn't have to kind of convert schemas all of the time when they're trying to kind of do research or do longitudinal analysis across different systems. This is really common when we talk about clinical trials, where if you're running a clinical trial and you're getting data from multiple different health systems, they could, in the previous world, that could look very, very different. Blood pressure could be 2 columns. It could be, basically a fraction, systolic over diastolic. And they have to do that kind of data munging for each individual hospital. Fire is really changing that now. They're going ahead and specifying and standardizing the way that healthcare data looks, feels, and interacts in the industry. And so what does this mean? There are a lot of now kind of Fire servers where, as I just mentioned, there's very specific schemas, thousands and thousands of essentially fields within the standard, as well as unique operations for Fire. There's cascading operations. There are chained operations. There's specific search operations. So something, for example, you can say, give me everything about this encounter. And it has to know to provide back all the observations, all the lab tests, all the diagnostics, the patient, the providers about a single encounter. That's actually a defined operation. It really says encounter everything. And so a lot of the industry is now building these servers that say, we'll maintain conformance of Fire so that you can use this, build with it, and not have to worry about actually maintaining and building out each of those operations or each of those nuances yourself. So in order for us, to do that, you generally speaking have your CRUD operations, you have search, there's import and export, which I'll talk a little bit about. And then you have things like change notifications in order to be able to trigger downstream impacts. So if I write to the Firestore and I need an app to be able to do something about that, maybe I text the patient, hey, your lab result's ready. That notification ability is really critical when kind of building up really end-to-end workflows on this. And so the reason that it's not as kind of easy, most people look at this and say, well, why can't I just put a database in there? And the reason, other than maintaining Fire conformance and maintaining all of the operations and things that it requires to be conformant, especially now that the U.S. government, or many governments are kind of very actionably doing things about this in terms of either charging if you're non-conformant or putting you on the naughty list essentially is what happens. But so it's very difficult for people to manage this on their own. But there's also so many nuances in the healthcare world that's different than a traditional kind of database. So transactional kind of synchronous writes and reads. That's a really complicated and hard problem when you talk about how can something be scalable and consistent. Well, in the healthcare system, a lot of this needs to actually be consistent because you can't necessarily have dirty reads on a database. If a patient has an allergy and it hasn't indexed yet, and you try and go and read that allergy and you don't see it, that could be an adverse event for the patient. There are also things where you don't want race conditions. Those could really also mean kind of adverse events in this world. And so there's really important kind of indexing and consideration about what needs to be transactional and what can be slightly delayed, or a longer operation without lot contention has to be considered when thinking about this. There are also aspects of the FHIR standard that include things like PDFs. Everyone probably has gotten their fax before or their PDF before. So actually, it's not just a structured database. There's also an unstructured blob storage associated with FHIR, where you have to be able to put your PDFs into, or maybe you just have a clinical note, or you're getting kind of any kind of documentation that doesn't necessarily belong in a single row or a single cell of a database. And then the third is really just how it gets searched. We have terabytes and terabytes of data in kind of single customers. And that, you run into the scale problem, which is how are you ensuring that care can continue, and then that this isn't performant as possible while you are trying to maintain a very large database, where at the end of the day, search is an extremely important aspect of the whole system, where if a patient has a bad experience where it's taking too long to search, that's not great. But if the provider needs that information in order to make an action on the patient, and your search is taking too long, that is a bad situation. And so there's really kind of complicated and burdensome things that need to be considered when thinking about healthcare that don't necessarily come up if you're just designing a traditional database system. And so that brings me to okay, so then this is an API layer, a database layer, but most folks actually are interested in analytics on top of that data. And so the way that I talk about the difference of our APIs, and I'll do a little bit of a demo here, is the APIs are the integration. It's what connects the world to patient. It's it's really what brings together applications or hospitals to hospitals for them to do data sharing. It's the communication layer. And then there's an analytics layer. The communication layer needs to be transactional. It's built on an OLTP database. The analytics layer is meant to be an OLAP database. And so you actually can separate them out, because since most of the integration layer is basically business critical, the analytics layer should not, it tends to be separate from the integration layer, so that it's not competing for compute resources, or they can run huge load tests and not impact the performance of the initial layer. And so we tend to see both, and we actually have built out the ability to do both. So I'll bring us over to a little bit of our Google Cloud UI. This is the healthcare UI. So if you are in the Cloud Console, there's healthcare, here's browser. What we do is we call this a data set. Data sets are essentially just a folder that allows you to kind of house things within it. I'm going to real quick just show data store so that I can run an operation on it. As I mentioned, we have multiple different types of data. So DICOM is the imaging data. HL7 is actually messaging. So whenever the clinical system sends messages, it comes in as what HL7v2 is. And then I'm going to show FHIR. I'm going to call this DID because I'm going to run a DID operation. And then you can do things like this. There are multiple versions of FHIR. There is even more versions coming out. So R4 is the latest, and that's what most of the implementation guides are on. We actually have a new, next year, for those who are in the US, a new implementation guide coming out in R5. And so we consistently see upgrades happening on what the data is, and that's kind of being managed by the US government along with the community. So this is, as I mentioned, you can stream changes to BigQuery, and BigQuery is kind of our OLAP database. That was the analytics database, and I'll demonstrate that as well. So we have automatic configuration between the two where you can export your data to BigQuery, and then you also can have the ability to receive notifications on the data. PubSub is essentially like a Kafka or a messaging bus that really just alerts when there are changes to the database happening. And so I'll go and do, let's see, I'll pick one of these. As you can see within the actions, I have we have kind of multiple different options of actions. So you can import data, export data, de-identify. The real nitty gritty, if you're running searches, although I'll show this, CRUD operations, if you want to do complex logic, that would all happen through something like Postman, or you can use the Cloud Shell. Our UI is pretty much more for an admin or setting things up that you would be able to do. Let's see. Pen. So what I'm doing right now, and I'll demonstrate this, is right within our console, we actually have the ability to de-identify FHIR resources. So as you can imagine, there's a lot of kind of sensitive data within the healthcare API. But a lot of our organizations want to be able to have researchers explore the data, but in a very secure and safe manner. And so de-identification is one of the ones we built in. It's actually built on top of our data loss protection tool, which I believe you will also get a demo of this after. And so this is kind of one way of de-identifying. We also have other tools within the Google Cloud product suite that allow for this. So I'm going to real quick show a quick kind of overview of what these actually look like. So I'll pull up all the resources, think of them like tables. So practitioner as a table, patient as a table, organization as a table. And so we're kind of looking at the patient resource and who they are. What it looks like from a raw data perspective is, and this is synthetic data, it is this kind of complicated JSON object. And so what I mentioned when I was talking about what FHIR defines, this is a good example where FHIR actually only defines 3 elements that can be within gender. So if you tried to send F, for example, it actually will be denied because that's not conformant with the gender code base. There is also a sex. So, when we talk about all the options that can kind of be available to an individual and their preferences, there is a category for that as well. And the U.S. government maintains, I believe there's I think 13. They have a value set for sex as well. Gender right now is currently has 3, and if it doesn't conform to one of those 3s, it actually would be rejected from a FHIR server. And those are one of the things that it's actually kind of working towards normalizing the data and being able to better have easier communication and easier automation between kind of when sharing this data, say between a provider and a provider. And so you can do things like search the data. Either we have query builders on here. And then the only other one, real quick before we go, it might have 1 minute. We'll try. Let's see. Great. So the de-identification that I had run earlier, you can see now all of the patient identifiers that were up here actually are no longer there. So if you look at the JSON, it's essentially empty. And this is configurable, so you can decide maybe you actually wanted to leave the post code. I have mine set to say states, but not zip code. But this is all configurable. This says a birthday. It's actually a date shift. So the way that we do it is we maintain, we randomize, but all things that are done together are date shifted in the same proportion. So it's still actually relative to the data set that it was de-identified against, but it's not their actual birthday. And so there's kind of a lot of different things that we do here based on your configuration and how you set up de-identification. The final thing that I will do before handing it off is just showing really quick a little bit about what this looks like in an analytics database. So this is BigQuery, which is where most of our customers are running large scale analytics or dashboarding or what have you. The BigQuery public data set actually has a public data set for that synthetic fire. So instead of you having to go do this, you actually are able to play around with it directly here. As you can see, all of the resources that I was mentioning actually end up as tables in BigQuery. So patient just ends up being a table in BigQuery, and you can have all of the elements that were here. So gender, birthday, things like that, and be able to access it. The one issue that we hear a lot from is what you're looking at. This schema is actually a defined schema by the community. It's what's called SQL on Fire. It is a gnarly schema. So it takes the JSON and it leaves it in those nested kind of arrayed columns. So you end up with a lot of columns that just look like this. And that's because it's maintaining the nesting of each of this. But it's a very, very sparse data set when you kind of look at it. And it's actually very difficult to query as well, because what ends up happening, here we go, what ends up happening is when you try and query, say, the address or the state, although I'm interested in that state, you need to be able to run really kind of gnarly unnest queries. So here's an example query of what just trying to find an A1C looks like. It's all of these safe offsets, and kind of gnarly joins that happen. And so as a community, we're actually moving towards better flattened views. So if anyone's interested in the project, it's called SQL on Fire V2. And it's going to allow for each use case to define a view and be able to kind of export that data in just the data that they need in a much easier to understand and kind of easier to grapple with manner. And so with that, I will kick it off. I think that's probably a good stopping point, because I think Faisal is kicking us off with BigQuery as well.
Yes, absolutely. So, hi everyone. First of all, absolutely amazing presentation, Vivian. I learned a lot, even though I've worked with this API before. So it's fantastic. And what's very interesting is some of the times I've worked, there was a dental clinic that I worked with about 3 years ago, and they were building like a completely cloud-based dental clinic. It was very cool. And one of the interesting things that they had built was this way of uploading images and text to Google Cloud Bucket Storage, and then that data being sent over to all these different Google services. And one of the problems they had, well, they had two problems. One, they didn't want certain data in that data set. So yes, they wanted a person's, say, phone number and name, but they didn't want like SIN number accidentally appearing in the data set, because that's going to cause them a whole lot of issues. And what happened was their doctors and their dentists, I guess, would accidentally type that information in, or it might not get redacted properly. So these guys wanted that data completely deleted. And so the solution we started to use was Google DLP, what Vivian mentioned. And I'm going to show you DLP from a different angle, which is that this data is going from a Google Cloud Storage bucket, and it's somehow ended up in BigQuery through whether if it's directly being read by BigQuery through or being sent over data flow with a bunch of processing happening. And in this case, I don't have SIN numbers, I have phone numbers. So let's just assume we don't want phone numbers in our data set. So I'm going to share my screen here, and we'll go over two things of what we can do. So here I have a data set. And if I click on preview, I have names, I have people's phone numbers, and I have some metric 1, metric 2. Forget what that is, probably something to do with, I don't know how many cavities they have. So here we have a bunch of phone numbers. And this data is just being brought in. Now imagine that they didn't actually want phone numbers. Specifically, they just didn't want this column. But that column ended up getting there, and there's a bunch of data there. So we could run a test on DLP and see, is there data in this data set that I don't want? Assume this thing wasn't called phone number, but it was called like address. But instead of address, there was phone numbers being inputted. It's a better use case. So what we could do, and it's very easy in BigQuery, I mean Google Cloud, we can just go to DLP. It's called data loss prevention. And I can I can go inspection. I can create an inspect job. And here I had an inspect job done before, so I'll show you the result of that. But I can create a new job, and I can point to where my data is. So I'm going to go through, write in a job ID, test DLP, and I'll go through, type in my project ID, dataset ID, table ID. I'm not going to fill all that out because I already have the job finished. And then I can run a sampling method, and I can say sample this data at random. So, if you have millions of data rows coming in, you might feel that it's much more better to sample it because you're sure that, I want to make sure my mic didn't mute. Yeah, okay. You want to make sure that data, you're sure that data is not coming in, but you just want to double check. So sampling makes a lot of sense. Sometimes you don't want any sampling. Like if this data ends up in if this say SIN number ends up in your data set, the whole company's finished or something. So in this case, I'm going to do no sampling because my data size is so small. It's just like 6 rows. And then what I can say is inspect all columns, or I can specifically choose which columns to inspect. So I can inspect the notes column to make sure that phone numbers and SIN numbers aren't showing up there. So I'm going to continue here. Oh, I guess I'm going to have to type this in to get to point 2. So Faisal's ML Playground, DLP test. Okay, so here's what's really cool about DLP. You can choose what you wanted to identify. So I'm going to disable everything. And let's say we want to make sure that there's no phone numbers in the data set. So I'm going to go to phone, and I can find phone number. Great. So now automatically anything that matches a phone number, it's going to automatically identify and say, hey, there's a phone number in this data set. You should be looking at this. Or I can find, say, the SIN number or a healthcare number. I don't know where. Yeah, so Ontario Health Insurance Number. I'm in Ontario, or the US Healthcare number, UK Health Services number. So you could select a bunch of these services that you want to enable. So OHIP right there, then I can hit done. So in this case, I'm just going to choose phone number. Sure. And then I hit done. And then I can just say, you know what? Whenever the results are, I want it to save to BigQuery, like all the stats, or I want to be notified by email. I want to push to cloud monitoring, maybe push to security command center if anyone's used it. It's just like one central place where Google's scanning all your assets. So your auditor can go in, your developers can go in and make sure that, hey, there's no like breach here, or we've identified something. I can hit continue, and I can say, you know what, run this every hour, every 24 hours, or run it only a one-time job. So in this case, I'm just going to discard this and go back to the job that I ran. And in this job, I just selected everything because I wanted to show you all types of things we can find. And if you remember how our data set looked, we found people's name, which is fantastic, which is what I wanted to find, as well as phone numbers. There's only 8 records in there, obviously, so great. It went through 8 records, and it found successfully that there was people's names and phone numbers. It didn't, thankfully, get confused by email addresses or encryption key. So this is great when you're sending all this PII sensitive data over to BigQuery, and you want to possibly not have certain types of data and be notified when that data exists. But what if you want this data, right? Say, what if it's very important for you to have phone numbers or something highly sensitive like a SIN number or someone's health identification number? It's very important to store it, but then your data scientists also have access to this database, right? Maybe you have contractors access to the database. You don't want some random contractor that's working on this data set building machine learning models have access to a phone number when it's completely not relevant. They just need access to maybe someone's date of birth. So what you could do is you could create policies to basically say, hey, in BigQuery, I only want these people access to a certain column. So let me show you how that works. So I'm going to go into BigQuery, go into my DLP data set, DLP test. Okay, so let's say I'm a contractor. I come in, I'm looking at all this sensitive data. I'm going to query it right now. I'm going to go select star. And that's it. I've probably breached a bunch of, like, the company's in breach now because now I have access to full name and phone number when I only need access to metric 1 and metric 2. So how do you, as a company, prevent this? Well, first, you can create 2 data sets, join it by a private ID, all that stuff. Too much work. Imagine you have terabytes of data already. Or you can add these row policies. So you can go back to your DLP test. You can click Edit Schema, column policies. You can click Edit Schema, and then you can say, you know what? I want phone number and name to be a policy tag. And I'm going to assign this policy called open text test. And I call this sensitive phone. Technically, it should be called just sensitive. The name doesn't matter. It's just a label. But I'm going to choose this, and I'm going to hit select. Now, where did I create this? If you go into BigQuery and policy tags, you can create policies right here. So let me show you. I can create a taxonomy and I can say, you know what, this policy is called contractors only. And I'm going to give this policy tag a name. I'm going to just call it sensitive data. Right? I can create multiple policy tags, subtags, et cetera, et cetera. And then now I can enforce access, and only the people with the fine-grained reader role will have access to that data, or the masked reader role. Otherwise, that data they will not have access to, even if they do select star. So check this out. I'm going to go in and I'm going to, this new policy tag that I added, let's just add it again. Contractors only, sensitive data. And what's funny is I've not given myself that role. So you see this, you have restricted access to this data column. I'm not able to access it. So me as a contractor, I've come in and I'm looking at this. I'm like, okay, so I know in this data set, there's a name, there's a phone number, there's metric 1 and metric 2, which are the 2 things that I need for my machine learning model. But I'm not able to access data 1, data 2. So let's see what happens. I want to go to query, and I'm going to go select star, and I'm going to go run. That it does not let me query this. Access denied. User does not have this permission. I can run this query from any tool as long as I'm using my credentials. I do not have access because I don't have access to those credentials. However, I can go metric 1, metric 2, I hit run, and I get SQL right there, right? And I can do whatever I want as long as I'm accessing these 2 columns. So this is a great way to create these sandboxes and boundaries in your data set when you have very, very extremely sensitive data. And you can go, you can create these policy tags and you can get very fine-tuned. You can say contractor 1 only has access to phone numbers because maybe contractor 1 is doing something with phone numbers or SIN numbers, right? So you can go very detailed and be confident that Google Cloud or Google Cloud BigQuery specifically here is not going to accidentally leak your data sets, and you don't have to go crazy by creating multiple tables and then having to manage all this data. So yeah, those 2 I find are really useful when you're working with sensitive data such as healthcare data or finance data. It doesn't really matter. Anytime it's sensitive, these two techniques are great at making sure you stay compliant, as well as making sure that you're only giving the right data access to the right people. So with that, I will open it up to any questions anyone has.
I do actually have one question for both of you. What's the most interesting use case you've seen or heard of with the either the BigQuery or some of the healthcare pieces? Faisal, why don't we start with you, and then Vivian, you can maybe give us an answer, and we'll go from there.
I once worked with a customer with DICOM images where they wanted to build a custom DLP based on DICOM. And it was very interesting where I had to learn what DICOM was. And for those that haven't played around with this, it's very interesting. And so we had, terabytes, I think, of DICOM images that Google was easily able to scale. We were able to extract these metrics and then store them in BigQuery. And that's when we did all this policy tag work to allow specific people access to specific data. So I find that use case to be very, very solid in Google.
Yeah, I think there's a lot of fun ones. I think my favorite, just because I'm biased and it's internal, and working at Google, is so cool. But I don't work with the Google that everyone thinks of as Google in the search engine. But one day I got a call from the powers that be at Google Search, where they said, I think we want a back-end provider lookup on Google Search. So actually, when you go to Google Search and you look doctor near me, and it's telling you about insurance, and it's telling you about available appointments and things like that, it's actually using a lot of our services. And that was the first time I was like, yes, I'm working for Google Search, kind of a moment, because I could. My mom finally knows exactly. She has yet to figure out what the cloud is, but she certainly knows what search is. So I think that was a kind of cool moment for me.
Great. Another question, and Vivian, I'll go to you first, because it's along those same type of lines. If you think about what you can talk about that you know of in the next couple of years that's coming out, what would you suggest developers need to think about as they're doing any kind of design work in healthcare, where they're looking at how they would use Fire and BigQuery and all bits and pieces from across these ecosystems? What do you think they should really keep their eye on?
Yeah. So one of the big transitions that I've kind of touched on, but I'll double down on, is traditionally integration was custom per hospital, per software. It was very manual, and actually it disincentivized app builders from ever building in healthcare, because each integration took lots and lots and lots of time, and so it made it difficult to sell into. With the new legislation, they are actually opening up and standardizing the APIs that those softwares have. And so if you build an application on Fire, you can now go sell that and integrate with any of the hospital systems that are maintaining the Fire APIs, with at least in the US is a requirement. And so it's changing the game, because for a very long time, healthcare was a legacy. Only the big incumbents were ever going to win because they were so far ahead and it was so proprietary. That is entirely changing right now. And so we see a world where it's going to be significantly disrupted with this kind of open API ecosystem. And it's just the start of it. So, if I was an investor, investing in that kind of a space is really interesting.
Now, Faisal, the similar question, but I'll ask a kind of a different angle on it. When you think about some of the more practical parts of the implementations that you're privy to now, what are is there 3 tips that a new healthcare developer should be thinking of for a build for today?
Good question. I mean, when we were starting off using the healthcare API, the the easy thing is to just be like, well, why do I even need this, right? Like I can just like use ABC and just start throwing files around. So like but then that's gonna come and bite you in the ass later. So I would say, I don't know about 3 tips, but the number one tip is to very closely follow what Google has outlined, because they've made it very easy. It actually became very easier, and I don't know. This is probably because of Vivian's product manager magic there, but like 5 years ago, this API was very hard to use, and over time, it's become very easy. And when Google's reached out to the consulting company I used to work at, and we had to work with it, we worked with it in 2 occasions. And like the first time was documentation was bad. It was kind of complicated, but then like 2 years, something happened, and it just became very easy to use. And so I would say follow the documentation and the code labs. They're really easy to quickly understand what's happening and to use all this. They also became, there we go. And then they also have a lot of sample data. So when you're starting off, you probably don't have a lot of sample data. Even like when we were looking at DICOM, I found a whole bunch of DICOM images on Google's GitHub repo that they had specifically that's ready to start testing with. So that was great. I didn't have to go ask the client and say, hey, can you send me like some random DICOM images? So look at the sample code as well as documentation. They've made it very, very easy to get started. It's kind of like, okay, I guess it's just another API now versus like some daunting task that it was before.
That's
Yeah,
fun. I will also give a shout out to Code Labs, and there's something called it used to be called Quick Labs. I think it's now called Cloud Skills Boost, where it will spin up your entire environment, and it's not on your credit card. It's kind of an entire environment for you to go play in that will walk you through how to use these tools. So that's another awesome kind of getting started tool to use.
Great. Well, Faisal, Vivian, we really appreciate your time, taking the time to talk to the audience today. I'm going to steal the last word for myself. Part of why OpenText came up with this idea around the hackathon and the 5 challenges that we put in front of the audience was really because we could see that things were changing, and we could see how these new strategic partnerships, such as with Google and some of the other partners that we've been working with, we're really going to give developers a new way to interact with data and a new way to align the patient and doctor experience in such a way that it's easier for everybody, and we can kind of get to the personalization that, for myself, I've been in healthcare for 15 years. We've been talking about it, whether you're on the clinical side or you're on the implementation side, for 20 years, how easy this is going to be. And by easy, they meant you had to cry tears and give up your first 2 children. That was easy back in the day. So with that, I really appreciate your time. I want to say we'd love to continue the conversation. As we've told you in the previous Q&As, we have the OpenText community board where we're monitoring. We also have the Discord where you can ask questions live. For anybody looking for the link on that, that's on the hackathon page. It's right there in the Discord link. Will take you right there. It's open to anybody. So with that, have a great day. I hope this has really helped you move your projects forward, and I'm looking forward to seeing what comes out of this. With that, thank you and have a good day.
30 seconds to quickly visit. You can just visit the hackathon page, and a lot of you have questions regarding the last date. So that's mentioned in the hackathon page itself. The hackathon ends on September 15th or 16th, depending on your time zone. So that's the last date for making a project submission. So thank you, Shahid, for the wonderful session.